Welcome to VW 1.2. Today we're going to continue our work on factoring. So recall from class that we found that a cubed plus b cubed factors to a plus b multiplied by a squared minus ab plus b squared. And a cubed minus b cubed is equal to a minus b multiplied by a squared plus ab plus b squared. And we're going to use that here. So notice how these are a little bit more complicated. In this one, we're going to do a u substitution. We're going to let u equal 3x minus 2. So now I have this, u cubed minus 27. And I can factor in terms of u now. So I'll just rewrite it like how we did in class. That's u cubed minus 3 cubed. So that would be u minus 3 multiplied by u squared plus 3u plus 9. Now notice how this factorization is not done. We have to plug back in for a u because we're trying to figure this out in terms of x. So all you do is you plug it back in. So 3x minus 2 minus 3. And then let's just work that out. So 3x minus 2 squared, that would be 9x squared minus 12x plus 4. 3u, that would be 9x minus 6, and then plus 9. So now we have 3x minus 5 multiplied by 9x squared minus 3x, and we have 13 minus 6, which is positive 7. And there's our first example, done. So that's called a u substitution, and you can always use that whenever you see something more complicated, like this, because if we were to cube that, that would take us forever, and then factor 27 would also be pretty rough. So instead we use u to make it simpler. So here's another way we can do it. Hopefully when you see this, you recognize that would be x plus 5 squared. So at this point, we're seeing something in common here, right? They have a common factor. So we're going to try u substitution again. Let u equal x plus 5. So now I have 3u squared minus 4u. I can factor out u. Notice how this one's a lot easier than the last one. And plug it back in. So u is x plus 5. 3u, that would be 3x plus 15 minus 4. And look at that. We're factoring, or our factorization is done. 3x plus 11. Okay, so there's our first example with u substitution. Our last two examples for this video, it's going to be factoring with rational exponents. So notice how these look pretty weird, and that's mainly because of these exponents here. You've probably never factored something this complicated. So before we do this, we're going to think about factoring in general. So notice how we did this problem right here. This 3u squared minus 4u. We intuitively factor out the u from u squared and u, or to be more specific, u to the first power. Now the reason we do that is because yes, it's a common factor, but if you compare 2 and 1, 1 is the smaller number, which is why we just factor it out from both of these terms. So this 3u is a result of 2 minus 1. Because we can see if you take out 1u from this, you subtract the power. And this is a 4 right there, because that can be thought of as 4u to the 0, or 1 minus 1. Now, of course, we don't write these steps in algebra because they're very intuitive, but you have to understand that's what factoring is doing mathematically to do harder problems. So to show you exactly what I mean, we're going to do these right here. And we could use a u substitution, but hopefully at this point you're kind of seeing the idea, so I won't do it for these. We can identify that there's a common factor with the x plus 1. So we're going to factor out x plus 1 like that. And you compare these numbers here. So we can see that negative 3/4 is definitely smaller than 1/4. So that's what we're going to factor out. Negative 3/4, like that. Now think about what's left in the parentheses. If we take out this entire expression from this, all that's left is x. And we can confirm that's right by just multiplying this back in, and we get this term. Then plus, now this is the part where we have to understand what factoring is doing. When you factor out a term, the exponents again subtract. So just write 1/4 minus negative 3/4. And you're going to notice that's a very nice number. That is 1. Which means this whole thing boiled down to this. X plus 1 to the negative 3/4 multiplied by x plus 1 to the first power. And first power is great because that means these don't matter. And now our factorization is complete. It would be x plus 1 to the negative 3/4 multiplied by 2x plus 1. And we're done. So let's try one more here. We can obviously see that the x minus 1s are in common, so we're going to take that out. Now look at the exponents. You have negative 1/2 and 1/2. You always take out the smaller one, so take out negative 1/2. Now we begin the factorization. Only x would be here. X minus 1 to the 1/2 minus negative 1/2. And look at that. That is once again 1. So this is very similar to the last problem, and you're kind of seeing the idea here on how to factor things that are a little more complicated. Now let's do the final part. We're going to use algebra to do basic computation. So I want you to quickly notice that if I plug it in right now, the root of 6/7 plus 1 over the root of 6/7, and I square it, that would be pretty rough to work out. Some of you might be able to do it with a lot of power, but this is not something you want to do because it would take you so long. So put a quick note, we're not going to do that. Instead, we're going to use some basic algebra. So take this expression and let's just multiply it. That's x squared plus 2 plus 1 over x squared. Now notice how it's a little bit easier, because if I plug it in, that is simply 6/7 plus 2 plus 7/6. Now we can see our common denominator should be 42, so that's 36/42 plus 84/42 plus 49/42. Add all of that, that's 169/42. And look how we easily get that answer. Or if you noticed it, we could do a little bit different. I could write this as the quantity of x squared plus 1 all over x, and that's being squared. So notice how if I plug it in here, I get something pretty cool. You plug this thing in right here, that's 6/7, add 1, that is going to be 13/7, and then of course x, that's square root 6/7. So now we square it, that's 169/49, and multiply by the reciprocal, which would be 7/6, and take a look at that. Very clean, and we get the exact same answer as before. A little bit easier. So for the final example, we're going to do a technique called centering. And it's pretty simple. It involves taking these two numbers and finding the center. So for example, 13 and 15, the center number would be 14. So I'm going to let u equal 14. So again, you can just imagine 13 and 15 on the line, the middle number is 14, or the average. By saying u is 14, that would mean 13 is simply u minus 1. 15 is simply u plus 1. Now do algebra. It's u squared minus 1. And we know u is 14, so take a look at that. I plug it back in. You should know 14 squared is 196. Subtract that. That's 195. So there we have it. 13 times 15 is 195. So let's try it again on part B, 14 and 18. So the center, take a moment to think. The center is 16. So that would mean 14 in terms of u is u minus 2. 18 is u plus 2. Do algebra, u squared minus 4. Plug it in. 256 minus 4. Therefore, the answer is 252. Now notice how to do part C using algebra, centering isn't ideal because you wouldn't get a clean center, which means this method centering is good when you have two evens. So even times even, or if you have odd times odd. In those cases, you would get a clean center. But in part C, you'll see that the center is not very clean. I have an even here and an odd here. So instead, we'll use basic algebra again. But I'm going to let u equal the tiny number, the smaller one. I could use 17, but it doesn't really matter. So if u is 12, that would mean this is u times u plus 5, since 17 is 12 more than 5. That's u squared plus 5u. And take a look, that's pretty easy now. That's 144 plus 60. The answer is 204. So good luck on the rest of the problems and bring your questions to class.